Good morning. Today we're going to be looking at doing numeric derivatives of a function in Excel and then graphing the function and the derivative together. As we look at this, we need to remember the intuitive definition of derivative, which is that you should zoom in on a function until it looks like a straight line, take 2 points on this straight line, and take the derivative the good old-fashioned way, take the slope the good old-fashioned way by doing rise over run. The calculator definition, how most calculators do this, note that for most functions, we've zoomed far enough if we've zoomed in that the points are 0.001 apart. In doing this, we'll use what's called a balanced difference quotient rather than f of x plus h minus f of x over h, which leans to one side rather than the other. We'll do f of x plus h minus f of x minus h over 2h. And our formula, since h is going to be 0.01, is f prime is approximated by f of x plus 0.01 minus f of x minus 0.01 over 0.002. One of the advantages of using this version is we can look at derivatives and understand them without having gone through any differentiation formulas. So we just have this, we don't have any symbolic formulas instead. Our plan is we're going to set things up, and as we do with Excel, one of the things we want to do is build a template, and once we have the template, use that for several different functions. And so we're going to look at functions going from -5 to 5, first for a linear function, then a quadratic function, then an exponential function. Let me shift to the Excel worksheet. And as you see in the Excel worksheet, I have some initial setup of what my columns would be. I want the derivative as my final answer. In order to do that, I needed f of x plus 0.001 and f of x minus 0.001. I wanted to understand what f was, the places that I'll evaluate. We've said that we're going to look from -5 I'll do -4, and then I'll do quick fill so that we're doing from -5 to 5. The first formulas are easy formulas. I want A2 plus 0.001 and equals A2 minus 0.001. Once again, we do quick fill, highlight the 2 cells, drag down, and that evaluates at both places. Now I'd like to do the function, and in the first case we said f of x was equal to 3 times x, or 3 times whatever was in A2. The reason for setting up this is obviously I want to quick fill down, but then I'd like to quick fill across. And if I look at my formulas and show my formulas, I need to make this a bit broader to see show formulas. You'll notice that A2 has become B2 and become C2. So I only had to type the formula in once. And for me, that's a great advantage because I'm one of the world's worst typists. And then to get the derivative, why that was E2 minus F2 divided by 0.002, making sure that E2 minus F2 is in parentheses, so that I have my order of operations. And what I'm going to see when I do this is the derivative is 3. Well, that makes sense. If I have a straight line, I've already zoomed in far enough for it to look like a straight line. And the slope was 3 in the line, so when I zoom in, the slope is still going to be 3. In order to see a graph of this, I'm going to want to highlight x and f of x and f prime of x, and then insert a chart. I want a simple scatter plot, and this gives me the function and the derivative. The derivative of the function in this case winds up simply being the constant 3. I then said I'd like to do the same thing with f of x equals x squared plus 5x plus 7. And my comment was, so first of all, let's insert a text box. Our first function was f of x equals 3x. That was a straight line. The derivative is constant. The second function f of x equals x squared plus 5x plus 7. And I'm simply going to go in where f of x was and put in the new formula. That would be a2x squared plus 5 times a2 plus 7. I need the times between the 5 and the a2 because I can't do implicit multiplication in Excel. Then I simply take this and quick fill, and it will appropriately change the formula for the cells and go to the B's and C's as well. And now when I look at it, my function, my blue function, is a parabola, and my derivative is a straight line. So again, I have this template I can use, and with the template, I can look at the function and its derivative at the same time. For the third function, f of x equals 100 times 1.06 to the x. Once again, I'm going to simply have to change this one function, this one cell, and make it instead 100 times 1.06 to the a2. And then I quick fill. And after I've done quick filling, I again get the derivative computed for me numerically. And when I look at my chart, these are simply multiples of each other. If I format the data series and put one of them on a secondary axis, we see that they're perfectly scaled from each other because the derivative of an exponential function is a multiple times that exponential function. So this gives us a way of setting up the function and the numeric derivative at the same time and being able to graph them, being able to compute them and graph them without having any derivative formulas. See your teacher if you have questions. That's the end of the lesson.